The first talk in our final session is by Maryam, Tahhan, and Kevin Traynor, and Mark Gray at Intel, and it's titled Accelerating the Path to the Guest.
Oh, no, Maryam is perfect. Hi, everyone. Today, Kevin and I are going to talk about accelerating the path to the guest. So just a minimal legal disclaimer. It's probably the smallest one you've seen in a while, but there you go. With the rise of NFV use cases, virtual network functions require high bandwidth, low latency interfaces into the network function virtualization infrastructure. So to build the case for accelerating the path to the guest, we're going to have a quick look at NFV. We're going to dive into a couple of guest access methods, followed by a summary and some time for Q&A. So what's the story with NFV and guest access? Well, exploding traffic is creating unprecedented demand on the network. By 2017, mobile traffic will have grown 13x in the space of 5 years. And in 2017, there will be 3 times more connected devices than people on Earth. As such, service providers are looking to NFV as a means of reducing their costs and a way of enabling them to deliver more flexible and agile networks that allow them to also deliver more services to their clients. So what does this mean for a telco workload in the context of NFV? Well, a typical telco workload consists of small packets at very high data rates. So you want to get the packets in and out of these VNFs as fast as possible. One may even argue that these VNFs running the workloads will require near-native performance. That is, performance similar to the case where the actual workload is running on the host. And this is a need that can be satisfied by DPDK. But before we dive into DPDK's guest access methods, let's have a look at the very baseline guest access method, virtio-net. Virtio-net is a power-virtualized network driver based on VirtIO. It enables a guest with network access. A guest with a virtio-net driver actually shares a number of QEMUs with a number of virtues with QEMU, rather, a TXQ and an RXQ to be exact. Now, the mechanism by which traffic is passed is actually comprised of 2 parts, a data path and a notification path. Now, the data path represents the flow of traffic to and from the guest. As we can see from this diagram, all traffic has to pass through the QEMU process. When it comes to the notification path, we use it as obviously a means of notifying the guest or the host when packets are available for their attention. So this is realized by the tap device notifying QEMU of packet arrival. QEMU then sends an ioctl to KVM requesting that it interrupts the guest, and KVM finally interrupts the guest. So the performance of virtio-net wasn't great because of all the context switching between host, guest, and QEMU. This leads us to our first guest access method provided by DPDK.
Okay, so thanks, Mark. Through the default access method to the guest. But now we're going to look at the first accelerated access method to the guest that's provided in netdev-dpdk. So this is using Intel DPDK rings and IVSHMEM. So just a little bit about Intel DPDK. I know probably a lot of people are familiar with it, but one of the things that DPDK uses to make sure it's a good set of software libraries for packet processing is it uses physically contiguous memory and 1 GB huge pages. So the reason it uses these large huge pages is to reduce the TLB cache misses and to increase the time, or to increase the speed in which you can go from virtual to physical memory addresses. So in order to do this, it uses the huge pages file system. It's a pseudo file system. And so a DPDK application will open the file descriptor and memory map in the 1 gig huge page. So that's the piece of memory that we want to share between the host and the guest. So before we look at how we'll actually make that sharing happen, another thing that DPDK has is lockless rings. So these can be used for communication between 2 DPDK processes. So for example, if we know that we're doing some of our packet processing on the host and some on the guest, we need some kind of communication mechanism between the host and the guest to make sure that the packets are flowing correctly. So typically we'd have an RX and a TX ring for communication. So in terms of IV shared memory then, so IV shared memory is also known as Tahhan, and it was introduced into QEMU in 1.4.0. So originally, IV shared memory is for sharing POSIX shared memory objects. And a key point about it is it's always host-initiated sharing. So the host has to initiate the sharing by putting an IV shared memory device on the command line of QEMU when the guest is being created. So obviously, DPDK uses huge pages and not POSIX shared memory. So we have to make a patch for QEMU in order to open the huge page and allow that sharing into the guest. So that patch is available from 01.org or can be found through there. Okay, so let's see how it works. Okay, so when OVS is compiled with the DPDK flags turned on, it will see a 1 gig huge page, and it will take some of the memory and create some memory objects. So, for example, here we see the text got wrapped a bit, but it will create a mempool. So a mempool would be a mempool of buffers that it would use to represent packets. So that's the MBUFs, which is the DPDK representation of a packet. So that's what we want to share, but we also know we're going to have to communicate with a guest. So we're going to reserve some rings as well. So an RX ring and a TX ring are going to be reserved. So then when we run QEMU, we're going to, on the command line, put in the IV shared memory device, and we're going to put the name of the huge page. So QEMU runs, and the IV shared memory code in QEMU will interpret this information, and it will create a PCI bar, it'll register a PCI bar with a link to that memory. So at that point, I can go back one. At that point, IV shared memory part of the code its work is done. So there's no IV shared memory layer in terms of the memory. It's just purely to register the bar and have access to the memory in the guest. Okay, so then we run our guest application. Okay, so it's an OVS client. So this OVS client is available in the OVS tree, I think in the test directory. And it's just a simple packet shuffler. So it just moves packet forwarder. It just moves packets from one port to the other. So at this point, because they both have access to the memory, we can say it's truly shared. And they both will use the rings, the RX and the TX, to communicate between each other. So that's RX and TX from the guest perspective. So the guest will receive packets from the host. It will do some packet processing. In the OVS client case, it'll just forward, and then TX down to the TX ring. Okay, so we're just showing that it's just packet forwarding. So OVS client doesn't need to touch the memory pool and touch the membus because it's forwarding them only. But if there was a more advanced VNF, which would maybe have to drop packets or maybe modify packets, the shared memory is all available to it, so that could be done. Okay. So let's have a look at the kind of characteristics of using DPDK rings and IV shared memory. So in terms of performance, it's very, very fast. So there's no copies involved. It's just purely shared memory. The only thing you're using is the rings, and they're extremely efficient. Now, on security, the story isn't quite so good. So the host is sharing the full 1 gig huge page up to the guest. So even if the guest only really needs to look at the rings or maybe the mempool, all that memory is shared up to the guest. So that obviously leads to kind of security concerns, and also if you were to share that memory to several guests, they would all have access to that memory. So it wouldn't be suitable if you had untrusted guests in your system. So live migration. So we said earlier that it was a host-initiated sharing. So it was done at the creation of the VM. And you were sharing the host's underlying physical memory. So to try and move that onto another host would be extremely difficult, and it's not really supported. So In terms of compatibility then, so we saw that the OVS client in the guest has to use the DPDK ring API in order to access the packets. So the guest application would need to be a DPDK-enabled application. And obviously that means any kernel features that you wanted to have, you wouldn't have access to that. So in terms of future, what could be done for Ivy shared memory? Well, for one thing, obviously we have some patches for QEMU for Ivy shared memory to handle the huge page file system. So it would be nice to get them upstreamed, and have maintenance on them. In terms of security, there is a lot of work has been done in the DPDK libraries for this. So it is possible, instead of sharing the full 1 gig huge page to each guest, to just say the individual rings and to share them individually to guests. So that cuts out a lot of the security concerns in terms of shared memory. And there's a full library of DPDK code that supports the creation of the command lines you need for that. And also the patch for QEMU is available too. So live migration, that's going to be pretty difficult. It's not really clear how you would do live migration with Ivy shared memory and DPDK rings. So that's going to be a difficulty. Okay, so Maryam's going to talk through the next path to the guest.
So the next guest access method we're going to look at is Vhost-net. Vhost-net is the predecessor to Userspace VHOST. It was introduced to address the performance issues of legacy virtio-net. And with Vhost-net, basically, the virtio-net implementation is offloaded from QEMU to a kernel module called Vhost-net. Now, this accelerates packet delivery to the guest by reducing the number of copies and context switches required. So the data path now involves a copy from the tap device to the guest via Vhost-net. And the notification path is also simplified. It involves the tap device notifying Vhost-net of packet arrival, and then Vhost-net interrupts the guest through KVM. So let's talk a little bit more about this notification path. The fundamental unit of this notification path is what is known as an event file descriptor, or an event FD. An event FD can be thought of as a mechanism, as a wait or notify mechanism for user space applications or the kernel to notify other user space applications of an event. So KVM has a feature that allows you to take an event FD and hook it up into a particular guest I/O exit. This feature is called I/O event FD. KVM also has another feature that allows an event FD to trigger interrupts in the guest. This feature is called IRQ FD. So in order for the data path and the notification path to actually work, QEMU needs to share some information with the kernel module, Vhost-net. Now, the first piece of information QEMU needs to share is the layout of the guest memory space so that the Vhost-net module can translate addresses. The second piece of information QEMU needs to share with Vhost-net is the location of the vert queues so that the Vhost-net module can push and pull packets directly to them, or from them as well. The final piece of information that QEMU needs to share is the event descriptors that are the event FDs that are used to trigger and receive notifications to and from the guest. Now, this leads us to Userspace VHOST. The first thing I would like to draw your attention to is that the OVS data path, even though it's slightly blocked off there, is now in Userspace and is enabled with DPDK ports. Now, we actually get some pretty impressive performance with the Userspace data path and DPDK ports. And this is a trend that we'd like to continue when it comes to guest access. To do this, DPDK implemented a virtio-net device in Userspace called Userspace VHOST. Userspace VHOST manages, the implementation actually looks after the creation and destruction events for the virtio-net device. It also looks after the mapping of the vert queues into the vHost memory space. And the last thing it looks after is the triggering and receiving of notifications to and from the guest. So how the first two items are achieved, that is the vert queue mapping and the management of the virtio-net device creation and destruction events, is through the use of queues. With queues, we create a character device in Userspace that registers our virtio-net device with QEMU and also does the feature negotiation with the QEMU driver. Once it's done that, it actually maps the vert queues by finding and mapping the guest's memory space. So after all of that is done, the data path becomes rather simplified. It consists of a single copy from the vHost interface to the guest. Now, when it comes to the notification path, unfortunately, it's not as entirely straightforward as the data path. We had to introduce a non-standard kernel module called event-fd-link. And the reason why we introduced this kernel module is because we didn't want to modify QEMU to explicitly share the event FDs. And what this module does is that it just transparently shares the event FDs from QEMU to vHost. So the notification path remains relatively the same, other than that, pretty much. So this leads us to the current characteristics for Userspace VHOST. In terms of performance, as we can see on the slide, there are less copies. There are less copies and context switches. It's important to note that there is that one copy between the vHost interface and the guest. However, we are communicating directly with QEMU, which gives you a bit of a performance boost. In terms of security, we actually map the vert queues to the vSwitch D address space, essentially, or actually that should say the OVS, the DPDK netdev address space, essentially. And so tenants can't actually access each other as guests. So you do achieve a certain level of isolation. For live migration, actually, a solution does exist with DPDK. It hasn't been ported to OVS, but who knows what may come in the future. When it comes to compatibility, well, you actually have two options. You can either run DPDK in the guest, or you can run a virtio-net driver in the guest. So what does the future hold for Userspace VHOST? Well, in terms of performance, there's actually a zero-copy implementation for Userspace VHOST. The other thing we'd like to bring into OVS is mergeable buffers. So what are mergeable buffers, some of you may be wondering? Well, normally with QEMU, when you send a packet to the guest, packet is actually preceded by a virtio header. So every single packet that comes in and is pushed to QEMU is preceded by this virtio header. So with mergeable buffers, what you can do is actually just have one header for a bunch of packets. So you end up being able to transmit a lot more packets to the guest in one shot. In terms of other virtio-net backend enhancements, some of the things we're looking at are jumbo frame support and multi-queue support. Now, all of these performance features and the backend enhancements I mentioned are actually going to be wrapped up in a vHost library provided by DPDK in the next version of DPDK. And in the subsequent version to that, we're actually going to implement the vHost user interface that's provided by QEMU, and that allows us to get rid of that non-standard event-fd-link kernel module we were looking at in the previous slide. At this point, I'm going to hand back to Kevin. He's going to talk us through some use cases.
Okay, so just really artificial use cases here, but so we've looked at two accelerated paths to the guest that are enabled in netdev-dpdk. So let's see which one would fit with which use case. So this is really easy. Okay, so in the first case, the user wants the highest possible performance. So they're not really willing to sacrifice copies. They have trusted guests, so they're not worried about guests snooping on each other's memory. And as a VNF, they're using a DPDK-based application. And for this user, no live migration, so they're not too worried about live migration. In the second case, the user still wants acceleration in the performance, but it's acceptable if it's a bit lower. They may have untrusted guests in their system, so they don't want to allow the ability for anybody to snoop. And they can run DPDK and virtio-net VNFs. And this user would like to do live migration. Okay, so I say pretty easy, but these are DPDK rings and IV shared memory would suit the first user. Userspace VHOST would suit the second one. So I guess in terms of being availability, DPDK rings and IV shared memory is on master, and Userspace VHOST is available as a patch. So I say obviously these are very artificial use cases, but in reality a trade-off would be required. So we won't do any trade-offs live on stage with engineers because it could go on for a long time. But so I guess to summarize, as Maryam has explained, NFV requires high bandwidth, low latency interfaces. So that's what the telcos need. And we've looked at 2 accelerated paths to the guest that are enabled through netdev-dpdk. In terms of which one is better, well, it's a trade-off: performance, security, features. I suppose the final point I'd make is DPDK has an active community supporting it. Some of you may be contributors. So new features will crop up all the time. And if there is new features you're interested in or interested to help to contribute, if you're interested in netdev-dpdk, please do. So that's it. So Q&A.
So we have almost 10 minutes for questions. Who has the first question?
All right, I got a question. For both of those cases, you were looking at Userspace OVS, right? In both case 1 and case 2?
For the IV shared memory
Yeah.
and Userspace VHOST, yes.
Okay.
So netdev-dpdk runs in Userspace.
Right, yeah. So have you ever looked at doing a similar thing for the in-kernel OVS data path?
As in, like, having a tap device attached to Userspace port, which is then accelerated with IV shared memory or Userspace VHOST?
Yeah, like doing the zero copy from Vhost-net from the driver itself.
No.
No, we haven't.
Okay. We toyed around with this idea for a little bit between myself and a couple of Red Hat guys. So maybe we should get together and talk about it sometime. It'd be fun.
Yeah,
Sounds good.
Hi, Romain Anglais, Oracle. I was wondering if you had any work on making this work for Xen, in addition to KVM?
Not at the moment.
Any plans?
If DPDK supports it, we'll support it.
So I mean, obviously, we leverage very much on the DPDK work. And you can see a lot of those features that Maryam talked about. We essentially can get them for free through DPDK.
Hi, I'm Madhu Chala from Neuro Networks. Do you have any performance numbers on like, say, NetPerf or some other benchmark, like for VM to VM test on the IVSHMEM versus the...
Yeah, so I know so we don't have any figures with us. I know there's benchmarking going on at the moment. So I'd hope in the next few weeks we'd be able to release benchmark figures. But just to give you an idea, like if you were to look at, say, other applications that have, rings and IV shared memory and have Userspace VHOST, so I've seen maybe up to, say, maybe 9 million packets per second for 64-byte packets, and I've seen maybe 6 or 7 million packets per second with Userspace VHOST. Now, the one caveat I will say is these are mature applications that have been built from the ground up for DPDK. So I don't think we'll necessarily reach those figures out of the box with netdev-dpdk. So it'll probably take time to optimize and to try and get good figures with them.
And a follow-up question is like, so when can we expect like the vHost user to be ready, like so we can actually test like VMs with OVS DPDK tunneling?
So are you referring to the vHost user API provided by KVM or just the vHost patches?
Well, for basically, so from what I understand, I mean, OVS already has support for user-space tunneling, and we cannot test VMs because the vHost user support is missing.
Yeah, so again, I think we would rely on DPDK for that. So is that a 1.8 or 2.0?
Yeah, it should be in the 2.0 release for DPDK.
Yeah, so I think that's Q1 2015.
Yeah. It's in Thomas from Noir, same context. Can you explain the difference between US vHost and vHost user? Is it referring to the same thing, or is US vHost DPDK specific?
I think it was just the naming picked by DPDK, Userspace VHOST. I don't think it was, and it was actually a predecessor to vHost user, the API that was suggested by SnapSwitch and was adopted by QEMU. Does that answer your question?
Anyway, we can combine the two together. You have one single vHost user or US.
So actually, the new DPDK library will just be called lib_vhost or RT lib_vhost, which should encompass the two, hopefully.
This is Eric Dubé from Red Hat. I had a question on the vHost user diagram. You mentioned something on, let's see if I can get it right, a NFVI link kernel module as a non-standard kernel module.
Yes.
Could you explain a little more on that?
Sure, absolutely. So the licensing is basically the issue there. It doesn't have that GPL license required for the module initialization, you know, that signature. So that's why it's called a non-standard kernel module, because when you insert it, you get that warning on the Verilog messages.
So that sits on the host side, right?
Sorry?
That sits on the host side, right?
Yeah, just on the host.
And where do you get that? Is that
the kernel module itself? It's actually part of the patch that's available on Open vSwitch on Patchwork.
Okay, great, thanks.
So hi, this is Raltan from Sixwin. I have a question about DPDK and the usage about virtio. So in dpdk.org today, there are unfortunately two drivers for virtio. One that we wrote at Sixwin, which is not using a Userspace IO framework. And there's another one, the libRT virtio, which is using the Userspace IO driver. This is the Linux Userspace IO framework. Do you have any opinion in terms of security? Because I know that there are some security issues also with the Userspace IO model. Do you have any opinion what will happen to these two drivers? I think they will merge, but do you have any preference using one of them, the virtio drivers?
I don't know if I have any preference. So obviously, ideally, it would be great if they would merge because you have less interfaces to be dealing with. But I can't really comment on DPDK strategy.
I guess the DPDK guys are probably more tuned into what they want.
And how about the security about the Userspace IO? Because obviously there's a difference between them. Otherwise, you know, that will be so cool to have the same driver. But did you hear about any security issues about that? Because, you know, there's a security part about copy, but the Userspace IO in the kernel itself, there are some debates on that.
I'm not sure, to be honest with you. Haven't really heard too much about it internally anyways.
Not aware of that, yeah.
Okay, I hope that they will merge at the end so that we can use only one driver so that no one is confused because all the vHosts already it's confusing terms. But
Thank you.
Do we have any more questions? Oh.
This is Roxana from One Convergence. So I was wondering, can you place SRAV in the context of these two solutions? Is it that the performance from SRAV is not comparable?
So I mean, I guess this is some of the work maybe John is looking at in terms of hardware offload. But I suppose we wanted to enable a DPDK path to the user space. You know, and that might be sufficient for some users.
So the last statement that you made is that you're saying that the SRAV path would be parallel to these implementations?
That's probably a question for John, actually. Yeah, it would be parallel.
I can try. You're getting my opinion, though. I think that there's probably still a slight performance difference between sROV and DPDK direct into the Vhost-net. I haven't done the performance benchmark to know, so I'm speculating. I think sROV, you also get the VTD of the hardware, right? So you'll have the DMA remapping occurring in hardware. So I think that's a big win as well.
The issue of an untrusted guest.
Yes, that's my understanding, or belief, I should say. Does that help? At least a couple of reasons, I think.
So, I mean, the way I've interpreted it is that you're saying that the performance with sROV is still lower than what we have with the DPDK?
I don't see why performance would be any lower with sROV. In fact, I would expect sROV to be higher.
Okay. So I'm just trying to see what is the rationale for three different solutions?
Okay. There are two different ways of trying to accomplish a similar goal, I think, which is to try to get line rate performance, low jitter, low latency into a guest. I think security is a big concern in the DPDK environment, and I think sROV resolves some of that. Yeah, I think it's a valid question. We should think about it. That's my belief and opinion.
All right, let's thank our speakers.